Okay, and welcome to everyone. As I mentioned, the fourth webinar series in our ACE webinar series, What is Engineering? Presented by both ACE Baltimore and Build Your Path. For those of you who do not know, my name is Kimberly Haar. I am the Strategic Partnerships Manager for MCCEI, as well as how many of you know me, the Affiliate Director for ACE Baltimore. A little housekeeping before we get started. As I mentioned, we are recording, so I do ask that if you are not one of our panelists speaking, you do stay muted. That way the quality of the recording will be the best as possible. If you do have any comments or questions throughout the presentation, there is a chat box feature, as you can see in, for most screens, the top right. But for specific questions that we will answer in the Q&A portion, we ask that next to the time in your top right, you should see three shapes, the triangle, square, circle. If you click on that, there's a Q&A section. That'll be the easiest to find all questions that we will address at the end of today's session. So for today's agenda, we're going to go over a background of what is engineering. Many of you students that are on the call today also attended our first session in our series, which was What is the Built Environment? We went over this content. This is a little bit of a refresher. And then for the majority of today's sessions, we're going to talk to our panelists on the call today about their experience in engineering. So what is engineering? In context of the built environment, engineers are partners on the design team with the architects. For those of you who have attended our What is Architect session, you heard a little bit about their role in the design team. Before the engineers, there are a variety of roles. They design the systems inside the house, such as the power, lighting, plumbing, structural, like the framing and foundations, and the heating and air conditioning systems. So engineers in general have a ton of responsibilities, but some of them include conducting feasibility studies and site inspections, developing project budgets, designing the complex systems within a structure, such as the power, heating, and cooling, ensuring compliance with government regulations, and clarifying the details for the various construction teams. So as I mentioned, there are a ton of different roles with the engineers, especially as it relates to the built environment, and that means there are various types of engineers. This is not all of them, but this is a wide variety that will be, again, discussed later as we talk to our panelists. One of which is a civil engineer. They're responsible for the design and construction of public works such as dams, bridges, and other large infrastructure projects. Electrical engineers that design, develop, test, and supervise the manufacturing of electrical equipment. Environmental engineers, which is the branch of engineering that focuses on protecting the environment by reducing waste and pollution. Mechanical engineers, which design power producing machines, and in the built environment, they often design the machines such as refrigeration and air conditioning systems. And structural engineers, which is a subdiscipline of civil engineering, in which they design the bones and muscles that create the form and shape of man-made structures. So again, a brief overview, but we mentioned this in the What is the Built Environment. But today we're going to hear from a few panelists that even in those roles and responsibilities do not uncover the whole breadth and depth of the engineering sector within built environment. So we're going to hear from a few of them today. I want to welcome Dominic, Joel, and Andrew. Thank you so much for joining us today. We're going to get started by having our panelists introduce themselves. The way this will run is for continuity, I will call on you guys in the same order, go through the questions one by one, and that way we can follow along if it's in the same order. So just as it appears on my screen, we're going to start with Joel. Joel, if you wouldn't mind introducing yourself, your title, the company that you work for.
Sure. My name is Joel Oppenheimer. I'm a senior vice president at STV Incorporated, and I'm a civil engineer and a professional engineer in 9 states and District of Columbia.
Thank you, Joel. And Andrew?
Hi, my name's Andrew Gordy. I'm a mechanical designer with Allen and Sharif Engineering in Columbia, Maryland. I'm an EIT, that's an engineer in training. And in a few years, I'll be able to sit for a PE exam. professional engineer exam.
Welcome, Andrew. Thank you. And Dominic.
Yeah, I'm Dominic Fuker. I'm a senior fire protection engineer. I work for Stanton Engineering. We're located in Columbia, and I am also a licensed professional engineer.
Thank you so much. So as you can see just in those intros, we have a variety of engineers that encompass all of the different types that are in the built environment. But we want to start in the kind of the beginning. So how, all the way back to childhood or high school or wherever it started, how you became interested in engineering or the built environment industry as a whole. Joel?
I guess you would say it's my aptitude. I love building things, erector sets, Lincoln logs, anything you could build, I enjoyed doing it. And when I was a kid, we would travel up to New York, and every time we went over a suspension bridge, I would make sure my parents would wake me up so I could see us going across the Delaware Memorial Bridge or the Verrazano Narrows Bridge. And I thought they were really cool. So I thought I would just design bridges, big suspension bridges.
Thank you, Joel. And Andrew?
Yeah, so a lot like Joel, I love to build things and put them together. But I think more than that, I like breaking things, tearing them apart to see how they work. And that sort of inquisitive nature really led me into engineering. You know, in high school, I took a physics class and really, really loved that. It really just sunk in for me. So, of course, I went to university and studied political science for a year. And, you know, a couple turns later, I wound up where I was meant to be, in engineering school. And there I discovered a love for energy efficiency, right? Looking at systems in the built environment and see.
Oh, looks like we lost Andrew for a second.
To, you know, the built environment and reducing our carbon footprint.
Andrew, thank you. And Dominic?
Yeah, similar to Andrew and Joel, as a kid, I always enjoyed math, science, and really just learning more about how systems worked. It was never enough just to kind of get a very brief overview of how something was working and how it was put together. And I was always more interested in finding out for myself how things worked in unison with other systems. So I focused a lot on math and science in high school and found myself in engineering school at the University of Maryland.
Thank you, Dominic. So as you can see, it's a lot about your interests and how many folks get into engineering, but it's not always from Andrew's story exact path. So if you're still confused, that is definitely the case. And we're hopeful that today's session will guide you a little bit more in that direction. But with that, I know all of you mentioned it slightly. Can you talk a little bit more about post-high school? What steps you took to enter the engineering field? Joel?
Sure. I was torn. I love buildings, and I thought, gee, architecture. I'll be the next Frank Lloyd Wright. I'll design these magnificent structures that everyone comes. It's a combination of art, which I love, and structures. And but ultimately, I enjoyed math and science, so I kept both paths open. And so I went through a little bit of architecture courses at college and some engineering courses, and I found out that I wanted to make money. And architects don't make as much as engineers, so I was told, and I think it's true. And I also just enjoyed designing things. And so each step of the way, I just did more and more math and science and engineering courses and found out that I liked it and I was good. And people came up to me in my classes, my fellow engineers, asking me to help them. So I think I was good at it.
Thank you. It's a common story. We heard it on the flip side. A lot of our students that are on the call today attended what is architecture and what is construction management, and that the industry is vast, but there are multiple different paths, and they cross over each other a lot. To your story, Joel, with architecture and engineering. Andrew, how about your story following high school that you mentioned a little bit? Oh, you're still muted. Sorry.
Yeah, sorry about that. So, like I said, I had a lot of competing interests, right? And I studied political science and decided to see if that was the path for me. And it turned out not to be. I think what's important is keeping your options open in that way, right? A lot of the courses that you take in your first year of college, they're the same courses you take in any program, right? And so it's really an opportunity to explore your interests. And so that's what I did, was got out and explored my interests, and found that the side of me that likes to tinker kind of won out. And so I, entered mechanical engineering school, and got to do a lot of that. And from there, kind of gained exposure to the field of MEP engineering, mechanical, electrical, and plumbing engineering in the built environment.
Great, Andrew. And Dominic?
Yeah, so like I was saying, I was interested in math and science, so I kind of had an idea that I wanted to study engineering in college, but really had no idea what any discipline was. So I wound up applying for electrical engineering school at Maryland, and got in, and it was headed in as an electrical engineer. And a couple months before that, I wound up meeting a gentleman that was involved in the fire protection program at Maryland, and he told me that I was able to play with fire for class in the lab, and there'd be plenty of job opportunities post college for me in the world. So I decided to switch to fire protection engineering, and I think no matter what you wind up doing, engineering wise, it's a challenge, but something to kind of push through and really challenge you to be a better person, not just in the classroom, but kind of focus your energy on one thing and be successful.
If I may hop in right at the tail of what you said, Dominic, the University of Maryland's program in fire protection engineering is a real gem. It's a real, really highly regarded program, and it's quite an opportunity that students in. Okay, so wanted to chip in with that.
Thank you. Yeah, it's one of the only A-BIT accredited programs in the country. So we like to say we're number one.
I want to.
Civil engineering at the University of Maryland is pretty good too. I didn't go there, but I teach a course each semester for the seniors in their capstone project. And luckily, Maryland, we're very fortunate for everybody on the phone. If you live in Maryland, you get in-state rates, and Maryland's an excellent school. So if you think you like engineering, give it a shot.
I want to do a little shameless plug. Thursday session this week is on Built Environment College Pathways. University of Maryland School of Engineering, as well as the School of Architecture and Planning, will be attending that session. We'll be talking to you all. So if you're hearing this today and you want to hear more about those programs and ask questions directly to professors, students, members from those schools that'll be attending, please do so. There'll be other colleges on the phone there as well, but just wanted to give a little bit of a plug. And so as that we mentioned, I gave a little 2-sentence brief of some of the various types of engineers in the built environment. My next question to you all is a little bit about your role within the built environment, as well as background on the organization that you work for and your specific roles and responsibilities. I think elaborating on that and what you do in terms of a project site would be helpful to the students. So Joel?
Sure, and I just want to double back for 1 second. One piece of advice: when you go off to college, keep your options open. I think you heard from all three of us that when you go in as a freshman, it's hard to know exactly what you want to do and what you love to do. You do have an opportunity at a university to try different courses and different curriculums. So I tried a little architecture, I tried a little civil engineering. The first 2 years, civil and mechanical go together, and then you can branch out. And one other thing I'll recommend is if you go to a university that has electives, try the business school, try different things, because you never know what you'll like. And they let you take courses in all the colleges. So it's a good way to see what you love to do. As far as your second question, I'm with a national engineering firm. I do a lot of planning and engineering design. Actually, I manage people now. I've been doing this for 40 some years, but when I was a younger engineer, I did a lot of planning of major projects, and it's fun to work with the public, to work with clients and help them solve their challenges. And so if I had to define my job, it's very simple. As an engineer, I'm here to solve my clients' challenges. And I like difficult challenges. I like for them to come to me and say, gee, we need this thought about, designed, and built in the next 7 years. I know that's next to impossible. Can you do it? And that's what makes engineering, it's solving a big puzzle, it's solving a challenge, and then it's working with many, many people. To be a good engineer, you've got to work with lots of people. You've got to work with public, you got to work with elected officials, you've got to work with co-workers in your company. You got to work with all disciplines. So if we're designing a building, we have the fire protection, the mechanical, the architects. It all comes together as a team project. And in the end, it's fun. I like being a project manager to help bring it all together and get a project done from start to finish.
Thank you, Joel. And Andrew, a little bit more about the company you work for, as well as your role within a built environment project and specific responsibilities.
Sure. So at Allen and Sharif, I'm a mechanical designer. So in an MEP firm, there's three components really: mechanical, electrical, and plumbing. And those specialties, they can overlap, but they tend to be different disciplines in a larger firm. And so a lot of my day-to-day is coordinating with my coworkers, making sure that they understand what I'm doing and I understand what they're doing, and the requirements of the project in that way. As far as specifically mechanical work, that refers to the HVAC systems in a building. So that's looking at the HVAC loads, for instance, and that's how we determine how much air conditioning a building requires. There's a lot of understanding and reading and complying with building codes as well. And that's true for any discipline of engineering, architecture, and what have you. Specifically in the mechanical realm, we look at ventilation rates, right? How much air, outside air, fresh air, do we need to bring into a building to keep it clean and healthy and smelling good? So that's kind of what a day looks like for me.
Thank you, Andrew. Good background into the MEP side of things. And Dominic?
Yeah, so I work with in a firm that's a little bit different than Andrew and Joel's. We're only 9 people, and we specialize in fire protection, engineering, and life safety. And so on my day-to-day, I'm working with other architecture and engineering firms, working with architects for life safety and building codes, letting them know how big they can build a building, how tall it can be, how many exits they need, how many stairs they need, and really dig into a lot of codes. There's a lot of research, and it's pretty fulfilling when you go down a long code track and find the answer and help the architect out of a sticky situation that they may get themselves into. And on the fire protection side, we do a lot of design of fire sprinklers, suppression systems, fire alarm systems, mass notification systems, and that winds up being a lot of coordination with other disciplines such as mechanical and electrical and structural. So we really work with all the team members on a design team, which is fun. And a lot of what we do is federal government work. So we're a small firm, but we're working on billion-dollar projects. Anywhere from a small tenant fit out to a large campus upgrade of a fire alarm system or a couple buildings being built. So it's pretty fulfilling, and I definitely recommend working at a small company. It's a little bit more personal and a lot more relationships, and get to wear a couple more hats. So besides engineering, I get to help on the business side of things, help on the marketing side of things, and just a really different kind of culture than working for a big company.
Definitely a common theme from all of you is mentioned that collaboration or teamwork on the projects that you do, and whether it be collaboration with the client all the way to your coworkers, or as Dominic recently mentioned, those other specialties or firms, which I'm sure all of you do on your projects. And with that, I wanted to pass it over into what has been your favorite project, whether it's been the experience in working on it or the final product that you were just wowed on yourself. I think we could say that working in the built environment, one of the biggest, and students who have been on our multiple sessions have heard this over and over, being able to go into a town or a city and see a building that you impacted in any way is extremely rewarding part of working in the built environment. So I'd love to hear a little bit more about your favorite project for whatever reason that might be. Joel?
Sure, and I'm going to do something dangerous. I'm going to try and share a window. So we'll see if this actually works. One of the unique things about the coronavirus is we're all learning how to do different platforms left and right. And I don't see the window. So let's see, because I got so many things open. Give me 1 second. Dangerous thing, always dangerous to not have practiced. Rule number one, always practice in advance. Let's see. I do not see my window. Let me go back one more step and see if when it says share. Sorry for this. I had a nice little picture I put together. A window, your entire screen. We'll try that. Nope. Nope. See, I'm on two. Let me try this. Okay. Here we go. There we go. Okay. Screen 2. We're going to share that. And
Thank you.
can you all see it?
Yep.
And I'm going to be dangerous and go into PowerPoint mode. Always dangerous to see what happens. Okay. So I'd like to just start off by saying one of my favorite things is starting on a project, having a goal, and delivering. And the project I'm showing you now was something I did back in 1985. I kind of fell into a planning project for a 46-mile freeway. But at the time, we didn't know it was going to be a freeway. We had to study it. And it basically begins, this is called Delaware State Route 1. It begins up at I-95. It ends just past Dover. And what happened was the state needed improvements to the existing Route 13, which had so many traffic lights, it took forever to go those 40-some miles. And it really needed a bypass of Dover, Smyrna, Middletown, and then to tie in I-95. And it was a great example of planning and engineering, because when you're a good planner, that means you also have to be a good engineer and make sure whatever you design is going to work. So here's the final product. I worked 3 years on this project and got all the federal permits, got approvals, got the public behind it, got elected officials behind it. We came up with the costs, we secured the funding, and then 5 years later or 7 years later, it actually got built. And every now and then you get to do a signature part of it. And this is a bridge. It's a cable-stayed bridge in Delaware, the first cable-stayed bridge in Delaware. It's over the Chesapeake and Delaware Canal. And to me, even though I didn't design it, I planned where it goes, what it's going to look like. And then we turned it over to bridge designers, a separate entity, and they designed this beautiful bridge. So that was thrilling. And there's another project that happened recently. I guess the point I'm saying is it's fun to plan out and be a part of a project that actually gets built. And what I'm showing now is the WMATA system of subways. This is the metro in Washington, D.C. It was 105 miles, and there's a new piece called the Silver Line. And if you see I'm pointing, oops, let me go back one. Jumped ahead too fast. It started at an existing station, West Falls Church Road, West Falls Church, and then split off, and it's going to the Dulles Airport, which is really cool. And I was instrumental in helping get through the first phase to get to what's called Wheelie Avenue through Tyson's Corner. But the best part about it is when I worked on the job, it was way over budget, and they needed someone to come in and figure out how to trim the cost to keep the job alive. I led a team of cost estimators. We got the cost down from $2.5 billion down to $1.8 billion, so we could get federal transit approval and get the monies for the project, and it worked. We got the monies, we got people behind it, and the end product is it's there today. The first phase goes all the way out to halfway to Dulles Airport. And you can see on the top left picture, the metro is in the middle of the highway. And that was all built as part of this project. And then the lower one is a station at Tyson's Corner. And this all had to be laid out and priced. And I was involved in the very beginning, which was a lot of fun. So in case you didn't know, I'm very enthusiastic about what I do. And it's fun to come up with something and delivering it, and then take your, for my wife's birthday one year, we stayed down at Tyson's Corner. We got on the metro. We went into DC and back on, and I told her everything about every station and the tunnel. And she was truly bored, but she appreciated that I loved the work that I helped accomplish. Thanks.
Well, thank you. Definitely a big footprint. You can obviously, there's a huge project to be able to look back and see the impact you had, which is exactly the sentiment that we started with, and that it can make you definitely enthusiastic about the work you do if you can see the product at the end of it. I think there's many lines of work that feel that way, but especially working in the built environment. If you have a specific project that you want to mention, show a little insight into the work you do.
Sure. So my favorite project really was the first one that I ever managed on my own. It was a small little 1,000 square foot job in a strip mall, and being able to be the main point of contact on something like that and really be the driving force that helps bring something to fruition really is rewarding. And that's a great opportunity that you get in the engineering field.
Thank you, Andrew. And Dominic?
Yeah, something a little different. I mentioned we do a lot of design work, but we also do a lot of different types of consulting work. And one of those is with the architect of the Capitol in DC. So the owners of the United States Capitol, Senate office buildings, House office buildings, Botanical Garden, Library of Congress, those buildings down there. And we get to work hand in hand with the fire marshal's office. I've been doing this for the past 6 years. We get to help them go through all of the historical buildings to do existing condition surveys. We're helping with construction period support. So going on to construction sites and making sure and ensuring that contractors are doing what the design plans that us engineers put together, they're doing those correctly. We're developing policy to help make the place a better and safer place. So it's really just a different aspect from design, but just the historical significance of the architect of the Capitol. It's really cool to be able to have that opportunity to work down there and with those folks.
Oh, Joel, you're muted. If you were.
A quick question, Dominic. Can you
Yes.
arrange a sprinkler system to come on if we don't like what we're hearing from either the Senate or the House or something like that?
Only if we started a fire.
It might cost your job, but it'd be kind of fun.
Oh, gosh. Thank you all. I think that's a great look into kind of the impact that you can have, as I mentioned. For those on the call today, we're about to enter into our last question. So if you have questions that you would like to ask, as I mentioned, please use the Q&A feature that you can find by clicking on the triangle, square, circle shape. Now's the time to put in those questions. To the panelists, the last question I have for you all is a very broad question. I know a lot of great advice has come through naturally through our previous questions. But if you have any last bits of advice for future engineers, whether that be traits or skills that they'll need, specific and coworkers or people you're hiring, if it's part of your role, things that would help in entering into the workforce. Now would be a great time to share that. Joel?
Well, it's a great topic, and it's actually, with my 40 plus years of experience, I actually have developed a course that I give to the capstone at the University of Maryland and many others, high school people, UMBC, you name it, I go there. It's all about the soft side skills of being successful. And in a nutshell, I'm going to start off with, you're going to learn a lot at college, but the day you graduate from college is the day you need to start learning. And one piece of advice I'll give you is, if you read 30 minutes every day, we'll call it Monday to Thursday, we'll let you have weekends off. But if you go home every night from work and read to learn something, it can be in your field, it can be how to have better skills. Every night you do that, you will become a much better person, an engineer and leader, and some of the areas that are critical to learn that you can't underestimate. Having the right attitude to be successful. If you want to be a leader and a great engineer, you need to be positive, you need to be proactive, you need to be grateful, and you need to be responsible. One other piece of this whole puzzle is you need to know your goals. Sit down and write out your lifetime goals every now and then and know where you're headed. It's very important. And then you need to manage your time effectively. The best engineers are the ones who get work done quickly. And as they say, there's a Pareto's principle. It's called the 80-20 rule. Always remember that 20% of what you do, the most important 20% of what you do creates 80% of the results. So if you make a list of 10 things you need to do in the next year and you put them in priority order and only work on the top 2 and successfully achieve those, you will have accomplished 80% of what you want to accomplish in that year. And the last thing that's very critical is if you're going to be successful, we talked about this, each of us has talked about this, you need to be able to communicate effectively with people. You need to be able to listen very well. You need to be able to watch body language. And you need to be, if you're going to be effective as a business development, an engineer working with other people, you have to be a very good communicator. And I'll give you just one quick rule. You have 2 eyes and 1 mouth. You should always be 2 ears and 1 mouth. You should be listening 2/3 of the time to everybody and speaking 1/3 of the time. If you flip that around, you're not very good at communicating. So learn as much as you can every day. That's my biggest advice.
Thank you, Joel. That was great. Andrew, before I pass it over to you, I want to mention one other thing to our students that I should have entered in today's discussion with. We have 3 wonderful panelists on today's call. Many of you are ACE Baltimore students, which is amazing, and you probably recognize some of our amazing mentors on today's call. But I also know we have a lot of females on today's call, and I just wanted to put a little mention out there that there are many female engineers, and while they're not here on today's panel, I wanted to make sure that that was known. And if you specifically would like to speak and have any conversations about what that is like being a female in engineering, please reach out to me. You guys have my contact information, but I wanted to put that plug before any of our students hopped off of today's call. Sorry to interrupt our question, but Andrew, if you would like to offer any words of advice.
Sure. So I'll offer my biggest piece of advice, and this really ties together all the parts of this question. It's the things that we're looking for in future engineers, things that'll serve you well, traits and skills that you need. And I think the biggest thing is the desire to learn things that may not be in a book, right? That may not be immediately given to you. I tell my coworkers something when they come to me with a question, and it's not to be mean, but I'll ask them, hey, did you Google this? Did you Google this before you asked me? And that's not because I have some secret information, right, that I'm trying to keep to myself, but I really think that by breaking things down and learning them ourselves and being driven to learn something, we understand it and we use it better. And so that's my biggest advice. Be hungry for knowledge. Go and dig up the answers that you're looking for. And I just wanted to say one more thing about, I think it was Dominic mentioned ABET accredited. The University of Maryland's program is in fire protection. That's a very, very, very important accreditation to look for when you're looking at an engineering school. Essentially, ABET is an independent body that verifies the curriculum of an engineering school and validates that it is up to par, so to speak. And that carries a lot of weight when you're registering for your professional engineering license. That's very important to look at.
Thank you, Andrew. And Dominic, any last words?
Yeah, I don't know how much I can add to Joel and Andrew. I didn't realize Joel was an expert in this. But I'd say just being a well-rounded person, as important as being a good engineer is, having knowledge about other things to be able to have conversations with people. I meet so many people that can't hold a conversation with another person, and a lot of what I do is not just looking at a computer screen all day, but talking to other people and getting to know other people. So I'd say being well-rounded and not just focusing on engineering only. That and being eager to learn and a good self-starter or self-motivator, you'll really go far in the industry.
Thank you. And again, I want to thank all three of you for joining. We did have one question, which I'm going to open it up to anyone who wants to take it. And if multiple people have comments, please do. A great question. Are there any effects or challenges that you face in your field on a regular basis? So anything that is particularly difficult or maybe a setback or challenge in your journey that you think would apply to a group? I'll open it up. Yeah, Dominic.
I've got something that's, kind of comical, but architects like to dream and, don't really have a plan of how they're going to do something. They just kind of draw it up. So a lot of what I do in building code and code consulting is killing architects' dreams and really just grounding people. So being able to communicate with your clients to let them know what is possible and what is not possible is always difficult. And in addition to that, just codes in general, trying to explain to a layperson why we have to do a certain thing and why we can't just ignore it is always a challenge. But I think that's what I see a lot of my day-to-day is a lot of explanations.
I would add on to what Dominic says about, killing architects' dreams. Something very early on in a project is a question that comes up for MEP engineers is how much space do we need for this? How much space do we need to accommodate your equipment? And one struggle that we face is being, how to put it, specifically vague enough, right? That, very early on in a project, we have to understand the backbone of what makes up that project and be able to convey the spatial requirements that we'll need. And that's something that we work hard to do.
Thank you. I think this very circles back a lot to, as you mentioned, communicating, obviously understanding your field, but communicating those requirements and those realistic expectations to the other members of the team. I'm sure architects have a piece of it, as you mentioned, Dominic. Clients, I'm sure, is a piece of it. For our ACE Baltimore students on the call, I'm sure your mentors and you all have discovered that in your concepts that you've created for previous projects. And as you're, diving into things and realizing, well, this is a great dream, but may not be realistic to be able to pitch that to fit the scope of the project. So very applicable for those students on the call. As it stands currently, that was our only question. It was a great question. But with that, I wanted to thank you. I think Joel had some technical difficulties. It looked like he was freezing, so he's left the call. But Dominic, Andrew on the call, I want to thank you so much for taking your time out of the day to share with our students. This recording will be live for anyone who has missed it. And I also want to emphasize all of you on the call today is because you have signed up for the ACE Baltimore webinar series. But please remember that they will be Tuesdays and Thursdays until about mid-November. Thursday is our What is the Built Environment College Pathways program, or Built Environment College Pathways. So if you are interested in hearing more, as we mentioned earlier, about University of Maryland, other people on the call will include Morgan State, Fairmont University. We will have Capital Technical University. So we'll have a few different groups. We'll be talking about community colleges as well. So please join us for that session and spread the word. Tell your friends. This is a great way to get some knowledge now in the fall virtually. So thank you all again. Andrew, Dominic, thank you for your time. Appreciate everyone.
No problem.
And we'll see you.
Yeah, thank you.
Bye-bye.
Bye.